Welcome back, and now we'll talk about actually using some of these tools in Nyuki. So the command line, if you go back to the documentation, you'll see the command line tutorial, and it will have all the details for for all the different Nyuki tools that I'm going to show you. Here's just the text version of it, but I'll run through each of these tools in with you. The first thing to do is to install or to download some sample images that we can use for our tests. So if you click on sample image small, it will download this file for you. I've already downloaded it, but you'll see that if you just download these files, it will save them in your computer for you. Okay, good. Once you've done that, now you want to go back to the command line. Now you want to make sure that you're in your Nyuki environment. Otherwise, you want to type, conda activate Nyuki env. If you do it more than once, it doesn't matter. But now the first tutorial to show you is just the information tool, right? And this is meant to be kind of a replacement or a simplified version of the GDAL info tool, if you've ever seen it. But what you would do is this will tell you some of the metadata about your file. So if I was to just look at all the files in my, you'll see that these sample images are here. If I was to just type Nyuki info -help, that will tell me how to use this info tool. And I think that's kind of the nicest thing is like, I always will go back and forth between like looking at the help thing to tell me what are the options. And so you'll see there's just two options, source file path, right? So all I would do is type Nyuki info --source file, and then the file's name is sample image small, and it will tell me some basic metadata about this file. The file is in this EPSG 32737 projection. It's a TIFF file. The file size is 1,312 pixels by 2,170 pixels. The units for each pixel are in meters, and each pixel represents 0.068 meters, which means 6 centimeters square. Each pixel is 6 centimeters by 6 centimeters, or almost 7 centimeters square. There are 3 bands. The bands are in 8-bit integers, and there's no compression on this image, right? So this tells you some basic information about the file. Now we found that this format is a little bit easier to read than if you were to use the alternative is GDAL info for the same file, right? That's the most common one. If you were to look at the GDAL info, it has a lot of information, but the problem is that it's hard to tell, hard to read this unless you're, have a lot more experience. It's hard to read exactly the information that you want. So you want to know that Nyuki is in, that this packet, that this image is in 32.737. But you look at this and it'll tell you all these different reference systems, and you got to look way down. You got to look around until you can find the one that you're actually interested in. Oh yes, here it is. So it's a little bit harder to find, and it's easy to make mistakes. So we made the Nyuki info look a little bit simpler. Now we'll add some of this additional information, but using Nyuki info is kind of nice because it's just a little bit more easier to read. If you want to look at a vector file, you can also use the same tool. So if we remember, we have a little sample vector, so we can say Nyuki info source file, sample vector file, right? And it will tell us information about this vector file. This vector file is in EPSG 4326, which is another common one. We don't have a whole lot of information in the vector file information yet, but we'll be adding additional stuff. And that tells you a bit about how to use Nyuki for getting information. The next thing we're going to show you is the compression tool, right? And there are a number of different compression standards. Geospatial, especially raster files, can get very large, so we like to compress them before sending them or uploading them to different places. The way that you would use the compression tool is to, well, remember that if you look at the Nyuki help, you'll see that Nyuki help, it'll list that there are 3 basic tools, right? There's the info tool, which I just showed you. There's a raster toolkit and a vector toolkit. So if I was to type Nyuki raster help, you'll see that there are 3 tools listed under Nyuki raster. There's compress, reproject, and resample, and we'll go through all 3 of these. So for compress, if we type Nyuki raster compress help, you can see these are this is how you would actually use it. This is what it will do. It'll actually compress your file, and you can see like you can see how to actually use this command. So if we wanted to see what the size of our current file is, we can see like the sample small image is 8.2 megabytes. Now if you were to type Nyuki raster compress source TIFF, in this case is sample image small, and the target compression standard, and you can use any of these standards. Let's try and use LZMA just for the sake of argument, or one as good as another. And you can type yes, it'll tell you the information. It's going to tell you what it's going to do. It's going to tell you that currently it's uncompressed and it's going to be compressed according to LZMA. It'll ask you whether you want to do this, because many times some of these processes can take a lot of time, and if you don't want to waste that time, then you can tell it to no. In this case, our file is pretty small, so it should be very quick. And we'll see now that we have this new compress file here. And if I wanted to see how much space I've saved, I can type ls-lh, and I will see that the original file is 8.2 megabytes, but the compressed file is 3.5 megabytes, right? And so that helps you understand how the files can be compressed. If you say wanted to uncompress a file just for the sake of seeing what you recover, you can actually do the same thing with typing none, right? So we just take our original file, small under compress. That was the file that we just compressed, and now we're going to uncompress it, right? So we can see what happens. And we'll add this -y flag, because that will just not require us to, not prompt us for yes or no. And it does it again, and we can now see that this is the file that we had originally compressed, and then we uncompressed it, just like the original. And we can see it's 8.2 megabytes, just like the other original one was 8.2 megabytes. And that shows us how to use the compress tool.